And so now what we're going to look at is how we go about working a matrix in order to solve the system of linear equations. It's through a process called Gaussian elimination. And so the way we do this is we get a 1 in the upper left corner, and then we use that 1 to get zeros down the next two entries in the first column to get zeros below the 1, and then we get a 1 in the middle, and then we get a 0 beneath that 1, and finally we get a 1 in the lower right position so that our 1's now are diagonal down the matrix. And underneath those 1's are zeros. So if we can write our matrix like this, we will have wrote it in what we call row echelon form. And in row echelon form, we can actually start to see what the solution to the system is. So I'm going to start working a few examples, setting up the matrix, and then going about the steps of reworking the matrix using row operations to make it look like this matrix in so-called row echelon form. Okay, so here's a system. We're going to start out with just two variables to make it a little bit quicker to get started with. What I want to do first is turn this into a augmented matrix. So now the first column I'm going to put 1 and 2 for the x coefficients. Second column 3, negative 1, and then I put the constants 5, negative 4. So this is going to be row 1 and this will be row 2. I want to make this matrix look like row echelon form where the 1's are diagonal and then the zeros are going to be underneath these 1's. So the first thing I notice is that up in the corner we already have a 1, so we're good to go there. The next step will be to try to take the 2 that's underneath that and turn it into 0. And we have to use row operations to make this happen. So the way I'm going to take that 2 and turn it into 0 is by adding a negative 2 with it. And if I add a negative 2 with it, it'll turn it into 0. I'm going to get that negative 2 by taking negative 2, row 1, adding that with row 2, and that becomes our new row 2. So negative 2 times row 1 is negative 2, negative 6, negative 10. And if I add that with row 2, 2, negative 1, and negative 4, that's going to become my new row 2, which would be 0, negative 7, and negative 14. So when I rewrite the matrix here, the row 1 stays the same, but the row 2 is the new row that I've changed. So that'll change it into 0, negative 7, and negative 14. So now I'm in the first step of row echelon form. The next thing is to get 1's diagonally down the matrix. So the next step would be to turn that negative 7 into a positive 1. The way I do that is by taking negative 1/7 times row 2 to equal out a new row 2. So if I take negative 1/7 and I multiply that by all the numbers in row 2, it would look like negative 1/7 times 0, negative 7, negative 14. That's going to be equal to my new row 2, which would go 0, positive 1, positive 2. So now my matrix would have 1, 3, and 5 in the first row, and then row 2 would look like 0, 1, and 2. And now this is what we call row echelon form because 1's are diagonal and there's a 0 underneath those 1's. So what we're going to do now is go ahead and take our matrix and write it back as a system with x and y. So the first row would look like, these are my x, this is my y coefficients, so it would go x, plus 3y equals 5. The second row would give me just y is equal to 2. So by doing that, now we have solved for the y variable. And what we can do is substitute y equals 2 and solve for x. And so if I do that, I would substitute that into the first equation. So it would go x plus 3 times 2 equals 5. X plus 6 is equal to 5. X is equal to negative 1. So our solution then for x and y would be negative 1, comma 2. Here's another system that I'm going to use matrix operations to solve. And the first thing again to do is to set this up as a matrix. So down the first row, row 1, that'll go for the first equation, 4, negative 1, and 5. And then for row 2, I'm going to put 3, 3, and 0. And again, I want to make this look like what they call row echelon form. So the first thing I'm going to see is the fact that I have a 4 up here in the upper left corner. That 4, I want to turn that into a 1. And we're going to do that by row operations. So there's no one way of working the row operations for everything. We can kind of work them in different orders in order to get the solution, depending upon what we see might work good. In this case, I'm thinking I could take the 3 from row 2, make it a negative 3, add it with the 4, or basically subtract the 3 away from the 4, and that would change the 4 into a 1. So that's what I'm going to do here. I'm going to take row 2, I'm going to go negative row 2 plus row 1 equals the new row 1. So if I take negative row 2, I'd get the negative 3, a negative 3, and a 0. And I add that with row 1, 4, negative 1, and 5. That equals my new row 1, 1, negative 4, and 5. So we'll have that down in row 1, and that's the first step to get to row echelon form. The next step is to take the 3 down here in the corner below the 1 and change that into a 0. I'm going to do that by adding a negative 3 to it. I'm going to take negative 3 row 1 plus row 2 equals the new row 2. So by multiplying row 1 by negative 3, the first number would be negative 3, positive 12, and negative 15. And we add that with the numbers in row 2. 3, 3, and 0. So our new row 2 is going to look like 0, 15, and negative 15. So now we are getting closer to row echelon form. The next step is to get the diagonal ones, so that 15 down in that side here needs to turn into a 1. The easiest way to take the 15 and turn it into a 1 is to divide it by 15. In row operations, that would be the same as multiplying the row by 1 over 15. So 1 over 15 times row 2 to get us a new row 2. So if I multiply 1 over 15 times row 2, we multiply 1/15 times 0, 15, and negative 15. That's giving us our new row 2, 0, 1, and negative 1. So now our matrix goes 1, negative 4, 5, and 0, 1, minus 1. And so now once we've got it in row echelon form, which now we do with the diagonal ones and so forth, We'll write this back out as a system of equations. So the first equation would go 1 minus 4y is equal to 5. The second equation would go y equals negative 1. So we've solved for y. Now we can solve for x. So that would be x minus 4 times negative 1 equals 5. X plus 4 is equal to 5. And so x is equal to 1. So now we can say that the solution to this system is 1 comma negative 1.